Calculating the lengths of other sides. Okay, so let's look at this triangle here. We have the hypotenuse is given at 26 centimeters. This length here is given at 24, and B, this one here, is unknown. So the question is, calculate the length of the side marked B on the following triangle. So we're not looking for the hypotenuse. Hypotenuse is given. We are looking for B. We can label these. This is going to be side A. B, of course, is unknown at B. And this will be C, the hypotenuse, because it is the longest side. This is a right triangle, so we can use the Pythagorean theorem, which states a squared plus b squared equals c squared. Now in this case, we're looking for b, so we're going to have to rearrange this equation. We want only b on the left side. We do not want a. So we can get rid of a by simply subtracting a. So if there's a squared here, we're going to subtract a squared. So let's rewrite this as a squared minus a squared plus b squared. And since we subtracted a squared on the left side, we'll do the same on the right side. So equals c squared minus a squared. A squared minus a squared, of course, those cancel, and we're left with b squared equals c squared minus a squared. So we have a new equation, b squared equals c squared minus a squared. We can use this to find the length of the side B. So we will put our value for C and A into this equation and solve. So B squared equals C in this case is 26. So we'll put in 26 and square it. And A in this case is 24. So we'll put in 24 and square it. So these will be relatively large numbers. You might have to use a calculator. 26 squared is 676. And 24 squared is 576. 676 minus 576, that's a nice number, 100. So we're looking for b squared, or we're looking for b, so we need to take the square root of b squared to get b. If we square root the left side, we square root the right side. Square root of b squared gives us b. Square root of 100 is 10. So the length of b is 10 centimeters. So we used Pythagorean theorem, we rearranged the equation for b, and then solved. Let's look at a second equation here. Calculate the perpendicular height of the isosceles triangle. Okay, so isosceles means two lengths are the same, and here they are. This is marked saying this is 6 centimeters and this is 6 centimeters. The base in this case has 4 centimeters. So we can't do much unless we have a right triangle. So we'll need to create a right triangle. If we were to slice this right down the middle, then this line right here, this would be perpendicular to the base, and that would give us 90 degrees. If we did that, we would be making a right triangle. So we'd have one length here, 6 centimeters, one length here. Now this is cutting the base in half, perfectly in half. So this length right here would be 2. And this right here is the height. We can label that H, or we could have called it B or A. So here is a right triangle. We have the hypotenuse, because this is the longer length. We have this length unknown, and this one is given as 2. So we can use the same formula we used in the last equation. Instead of rearranging again, we can simply write it b squared equals c squared minus a squared. And we just have to put the right values in the right positions. So now I'm saying that h is b, or I could simply relabel that and make that a b. That's a little bit simpler. So b is unknown. We're going to put in our values for c and a. So b squared equals, and c is the hypotenuse, so that's the longer side, so that's 6 squared minus a, in this case, is 2 squared. So b squared equals 6 squared, which is 36, minus 2 squared, which is 4. So b squared equals 36 minus 4, which gives us 32. We square root each side, and b equals the square root of 32, which you'll probably have to use a calculator, and you'll get 5.65685, and we can round that off and say that b equals 5.65685. 0.7, and the length is centimeters. So again, we rearrange Pythagorean theorem. We put the correct value for hypotenuse and then the other side, which gives us a formula which can solve for the unknown length.